Hello. um, Today I'm going to continue my presentation about the compressed air system optimization, a study case in a called fire power plant. And then in my previous presentation, I have talked about the air quality. I mean the compressed air quality, that we talk about the water content and also the particle content, oil content. So here we have some explanation about the application, and then the related to the class of the air quality. And as I will explain in the future in the next presentation about the compressed air quality is referred to the ISO standards, which is ISO 573/1 compressed air quality. And this standard divided the air quality in classes, from 1 up until class 7. The best class is the first, is the one, the class 1, class 2, and so forth. This the hierarchy of the class. And the relation between application and the class. For example, we can see in this presentation, in this table, let's say respiration air. Respiration air talk about in terms of particle content required class 1. It means they limit it, they limit the particle size up to 0.1 micrometers, which means this required that the maximum particle size prohibited in this application is just only up to 0.1 micrometer. So we don't need we can't we can accept the particle size of more than 0.1 micrometer for application of respiration air. But for general factory air, we required class 3, that we limit the particle size of up until 5 micrometer. So in general, in this application, they require lower requirement than the respiration air application. So in terms of the dew point, or the dew point is related to the water content in the compressed air. For general factory, it requires class 4, which means the dew point is the maximum allowable. The maximum allowable of temperature, dew point temperature, is 3 degrees Celsius. But for, let's say, for medical technology, it requires -20 up until 3 degrees Celsius. The class in between 3 and 4, 3 and 4. Or for spray gun, this application is usually we often see this application in the painting painting factory, for example, in the automobile fabrication, the spray gun required the class 2 for dew point, for water content. It means that dew point, the maximum dew point is minus 40 degrees Celsius. So this means that this application have a low tolerance to the water content in the compressed air system. Yeah, but in other case, for the in opposite, for the application in general factory air, they have a higher tolerance, higher tolerance to the water content entrapped in the compressed air. Yeah. If we take a look at deep into this standard, ISO 8573.1, the standards is launched at 2000, at year 2000. The standard categorized the air quality in three parts. The first part is related to talk about the solid particle or dust, entrapped in the compressed air. And then the second is the humidity and liquid water entrapped in the compressed air. And then the third one, the last one, is the oil content. Yeah, the oil level content in the compressed air. We classify the class from 0 up until 10, and the most popular, the most widely used the class is in between class 2 up class 2 up until class 6. Yeah. Class 2 and class 6 is most common application, most apply in the industrial. So as you can see here in this table, for instance, for solid particle dust or dust, for class 5 or for class 1, the most require the most quality air that we applied in industry. The class 1 required that the particle size of the dust entrapped in air divided into three sizes. The first size is from the 0.1 to 0.5 micron. It's talk about diameter of the dust, the size of the dust. And then the second one, they talk about, they also classify the particle in between 0.5 to 1 micron, should be not more than 400 particle, and then the particle in between 1 to 5 micron in size should be less than 10 per meter cubic, particle per meter cubic. So we can say that for the class 1, we limit the particle content for size in between 0.1 to 0.5, not more than 20,000 20,000 particle per meter cubic, and not more than 400 for particle in between 0.5 to 1 micron, uh, should be less than 400 per meter cubic, and for particle in between 1 to 5 micron in size should be not more than 10 particles per meter cubic. Yeah. Let's if we talk about the water content, we measure water content in term of dew point, pressure dew point. In term of pressure dew point, this is the significant parameters that related to the water content. So, for example, for the class 1, the dew point should be less than minus 70 degrees Celsius. And then if we take a look at to the most widely application is for the class 8 maybe. Class 8 is the most widely used because this is for the general application in the plan, general application in the plan, or many people say that this is for the surface air, surface air application, they require class 8, class 8. And for the class 8, the dew point, the pressure dew point should be in between 0.5 to 5 degree Celsius. It will be provided by refrigerant dryers, for refrigerant dryers. But if you need to reach, if you need to maintain the compressed air quality in for the class 1 up until class class 3, class 3, from class 1 up until class 3, you need install the absorption dryer. But for class 4 up until class 10, for class 4 up until class 10, you need to install refrigerant dryer. Okay, because the capacity or the maximum capacity of refrigerant dryer to produce compressed air with the pressure dew point minimum is 2 degrees Celsius. Minimum 2 degree Celsius. Lower than 2 degrees Celsius, you need other type of dryer. For example, you need absorption dryer, adsorption, or others or other technology absorption. There is there are the difference between adsorption and absorption, but both of this kind of technology is suitable for the application that need the pressure dew point lower than 0 degrees Celsius. Also for the oil content in the compressed air, they classify the oil content in class 4, class 1, 0 until class 4, and class X for addition. And then it states the total concentration of oil in milligram per meter cubic. Or part per million. Part per million. In this case, in our cases, we have measure on some location, more than 20 location, more than 20 point, to measure dew point and also the water vapor dew point and also particle content. But we don't measure the oil content because the type of the compressed air installed in this plant is centrifugal compressor. which is they need the oil or lubricant uh, to to lubricate their impeller or to lubricate their blades. Yeah, so there is in centrifugal compressor there is no oil entrapped in the compressed air system. There is no oil entrapped in the flow of compressed air. Yeah. It is different with the oil injected compressor. For oil injected screw compressor, um, they have to lubricate the, the screw. Yeah, they have to lubricate the screw. So this oil will flow with the compressed air through the distribution, yeah, through the distribution line. So it will impact to the end user of the compressed air, and we will have the problem in the future. Yeah, we will get the problem due to the oil content in the compressed air. Here we have in this table we have the result of dew point measurement, and the dew point is varies. Yeah, our result is varies in between 1 point minus 28.4 minus 28.4 up until 30.9 degrees Celsius, up until 30.9 degrees Celsius. So in the next column, we put the water vapor that related to the dew point, yeah, related to the dew point. For example, number 1, location after dryer and receiver tank instruments. Dew point is 9.3. It means that the water vapor is 417.93 gram per meter cubic. So the dew point 9.3 degrees Celsius is correspond to, it means that it had about around 417.93 gram per meter cubic. And basically for this application after dryer and receiver tank, it should be required the compressed air quality should classify as number 3, yeah, as number 3, class 3, yeah, number class 3, with water vapor is 30.7 gram per meter cubic, 30.7 gram per meter cubic. But in actual, we find that the actual situation, this point after dryer, it classified as class 4. It classified class 4 with dew point 9.3 degrees Celsius. So we have to improve, yeah, in order to require the standards, yeah, in other match with the standards. The standards mention that this application should be at least they classify as class 3, but the actual condition it classified as class 4. Yeah, as class 4. So from this table you can read the other part of the location, and then we state here the actual condition, and then what the standard need, yeah, what the standard need, and then the gap between the standard and the actual, yeah. Let's say for example, for after dryer and receiver tank, it should be class 3 with the water vapor about 30.7, but in actual they have 417.93 and 417.93 gram per meter cubic of water vapor. They have much higher, yeah, much higher water vapor than it accepted by the standard. Yeah. Okay. So from this measurement, we have some recommendation. The first one, the first recommendation is we suggest to installing water separators or on user side, installing water separator on user side to remove the potential of the problem in the next future due to the water content in the compressed air. The second recommendation is install electronic zero loss drain to dispose of wet water. The third one is periodically replace filter coalescing elements. And then the fourth recommendation, we suggest to evaluate existing dryer system. From the measurement after dryer in water treatment plant, dew point is 24.5 degrees Celsius. It should be between 3 up until 7 degrees Celsius. So it is considered to change both of dryers because it's no longer show the expected performance, and it is basically no longer visible. Yeah, from our visual observation, we look at that. We find that this dryer is physically no longer visible. The last recommendation is replace and or repair existing desiccant dryer. Measurement after desiccant dryer or absorption dryer. The other names of desiccant dryer is absorption dryer. So result that the point vary between minus 28.7 degrees Celsius to above 20 degrees Celsius. This indicates that some desiccant dryer are not functioning properly because basically desiccant dryers can produce air with dew point pressure ranging between 40 to 73 to minus 73 degrees Celsius. Between minus 40 to minus 73 degrees Celsius. Yeah, okay.